So here is the review for the test. The test is on Friday. So you got the review sheet yesterday. So here is the video of the review key. All right, so the first one, we're doing the inverses. So you look at the unit circle, you find where tangent is going to be 1. All right, tangent's going to be positive 1 on the right-hand side of the unit circle. Remember, we're looking, when we're doing inverse tangents or inverse sine or cosine for that matter, you're restricted to certain parts of the unit circle. All right, tangent is restricted to the right-hand side of the unit circle. So to get 1, we had to do root 2 over 2 divided by root 2 over 2, which is at pi over 4. So we have pi over 4. And we take the cosine of pi over 4, and we do the inverse sine of that. So we're working from the inside out. Now if we look at the cosine of pi over 4, that would be root 2 over 2. And then we do the inverse sine of that. The inverse sine of root 2 over 2 is, well, pi over 4. And we're done. All right, now again, the inverse sine is restricted to the right-hand side of the unit circle, right, which is why we could only do pi over 4 and not 3 pi over 4. All right, number 2, tangent of 5 pi over 4. So the tangent of 5 pi over 4, because it's not an inverse, it's not restricted to anything. So we find 5 pi over 4 on our unit circle, and it is negative root 2 over 2 divided by negative root 2 over 2. And those two things are the same thing, divided to each other gives you just 1. So we have put the wrong term. So inverse sine of that, and the cosine of whatever that is. So we do the inverse sine of 1. So looking for where sine is going to be 1 on only the right-hand side of the unit circle, because that's where it's restricted in its domain. So we find where sine is going to be 1, and that is at pi over 2. And we do the cosine of pi over 2, and find out that the cosine of pi over 2 is 0. All right. Number 3, the cosine of 5 pi over 6. There is no restrictions because we're not doing an inverse. We find 5 pi over 6, and the x term of 5 pi over 6 is going to be negative root 3 over 2. And we do the inverse sine of that. We're looking for negative root 3 over 2, and only on the right side of the unit circle because that's where it's restricted in its domain. Now, it is going to be at 5 pi over 3, but in order to get to 5 pi over 3, we had to go around the unit circle past the parts where you can't go for inverse sine. So instead of going around the unit circle, we're going to go backwards. So if you think about the unit circle, we're going this way. All right, because we're going backwards, it's going to be a negative pi over 3. Okay, which is coterminal to 5 pi over 3, but we had to go backwards to get there. So that's why it's negative pi over 3. And then number 4, the inverse cosine of root 3 over 2. Now for cosine, for the inverse of cosine, you can only use the top half of the unit circle, unlike sine and tangent where you have to use the right-hand side of the unit circle. So on the top half of the unit circle, where is the point where it's root 3 over 2, and that is going to be at pi over 6. So the x value is root 3 over 2 at pi over 6. We're going to do the tangent of pi over 6. So the tangent is sine over cosine, so it's 1/2 divided by root 3 over 2. We're going to multiply by 2 over root 3, 2 over root 3. Okay, all this stuff on the bottom will cancel, so will the 2's, and we'll be left with 1 over root 3. Now, we've seen this before, or you should have seen it before, where you can't leave square roots on the bottom of your fraction, so you multiply it to the top. So you get 1 times root 3 is root 3, and root 3 times root 3 is root 9, and the square root of 9 is just 3. So this is your answer for tangent of pi over 6. And those are the inverses. Okay, now we go to the equations. Okay, so we want to get the sine value all together and then solve for the sine of x. So what we're going to do first is we're going to subtract 3 sine of x. Oops, forgot a number. There we go. Then we're going to also subtract the square root of 3. Let's make this bigger. So this will go away, and this will go away. We'll be left with 5 sine of x minus 3 sine of x gives you 2 sine of x. And that's going to equal negative root 3. Now to get sine of x by itself, we're going to divide both sides by 2. So sine of x is equal to negative root 3 over 2. Now that's only part of the answer. Okay, that's good, but now you have to look at your unit circle and find out where is sine, what radians is sine going to be negative root 3 over 2. And there are 2 of them. It is negative root 3 over 2 on the y value of the point at 4 pi over 3 and at 5 pi over 3. Actually, you know what? There we go. All right. Number 6. Okay, we have to get the cosine squared part of the equation by itself first, so we're going to divide both sides by 4. So we have cosine squared of x is equal to 3 over 4. Now, to get the squared part, we square root both sides. So the square root and the square root will go away. All right, and then you're going to take the square root of both the 3, which doesn't have anything to do, and then the square root of 4, which can be just 2. All right, the thing many students will forget is when you square root both sides of an equal sign, you have to put plus or minus. So now what we're going to do is look at all the x values of our points on the unit circle and find out where they are, what radians they are when it's positive or negative root 3 over 2. So we have 4 of them. We have pi over 6, we have 7 pi over 5, sorry, missed one. 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are the 4 answers you should have for this equation. All right, number 7. All right, same kind of idea as the last one, but we have to get the cosine squared by itself, so we're going to subtract by 2 first. We have 8 cosine squared of x equals negative 2. All right, next we're going to divide both sides by 8. So we're going to have cosine of x, or sorry, cosine squared of x equals negative 1/4. And now I'm realizing we have an issue. Okay, so we're going to make a quick change to this problem. I do apologize for this, but I didn't see this before. So our change real quick is going to be change this sign from positive to negative. Okay, otherwise we can't take the square root of a negative number. It becomes an imaginary number, which is not good for us. So if we change the problem, this becomes positive. All right, and now we're okay. So one quick change. Now, if we keep doing our problem, we now have a positive 1/4, and we can square root that. So we take the square root of both sides, the squared part goes away, and the square root of 1 gives you 1, the square root of 4 gives you 2, and because we took the square root of both sides of our equal sign, we have a plus or minus. Next, we look at the unit circle. All right, so what values of x are going to be negative or positive 1/2, and what are those radians? So we look for all the pi over 3s. There's going to be 4 of them. So we have pi over 3s. We have 2 pi over 3. We have 4 pi over 3. We have 5 pi over 3. This is all the places on the x terms where it is positive or negative 1/2. All right. Number 8. Where is it? There we go. All right. So here we're going to get the signs on both sides that are on both sides onto one side. So we're going to add sine of x. Okay. Now, unlike the other ones that we've done before, we cannot combine 2 sine squared of x and sine squared of x because the one is being squared and the other one's not. So they're not really like terms. It would be like saying x squared plus x. You can't combine x squared plus x because they're not like terms. So we're going to rewrite them next to each other. And when we do that, we should realize that we can factor a greatest common factor out of this equation. We can take a sine out. And then we're left with 2 sine of x plus 1 equals 0. Now we have these two factors. We can set them both equal to 0 separately. We have sine of x equals 0. We have 2 sine of x plus 1 equals 0. Okay, so the first one is already solved for sine of x, so that one's done for now. The other one we have to subtract 1 and then divide by 2. So we subtract 1, divide by 2, we get sine of x equals -1/2. Now we're going to find out the radians for both of these answers. So where does the y value on the unit circle, where is it going to be 0? It is at 3 different places. It is at 0 pi, it's at pi, and it is at 2 pi. For -1/2, we have 2 places. All right, the y value is -1/2 at 7 pi over 6 and at 11 pi over 6. All right. Number 9. Same kind of idea that we just had. All right, we can take a tangent out of both of these terms. So we have tangent of x plus 1 equals 0. Now we can take both these factors and set them equal to 0. All right, the first one is already solved for x. The second one, we have to solve for tangent. So we get tangent is equal to -1. So now we can look at our unit circle. Okay. So for tangent of x equals 0, where is tangent when you divide sine by cosine? Where is it going to be 0? And it is at 3 places. When you take 0 divided by 1, it's going to be 0. So that's going to be at 0 and at 2 pi. It's the same place. And when you take 0 divided by -1, it's also going to be 0, which is at pi. All right, at the other axis points of 0, 1, 1 divided by 0 would be undefined, so that does not work. Same thing for -1, 0. -1 divided by 0. That would also be undefined and not be able to be working. All right, for the tangent of -1, we're looking for 2 spots. Okay, and these are where the pi over 4's come into place. If we do root 2 over 2 divided by root 2 over 2, that's +1, but we're looking for -1. So we want to have one of the values be negative and one be positive. So that's going to happen at 3 pi over 4 and at 7 pi over 4. Okay, at the other 2 pi over 4's, it would be +1. So these are the ones that would give you -1. So there are 2 separate answer groups for this number 9 question. All right, and then number 10. Okay, we have a bunch of stuff going on, but if you have 2 separate big terms, here's the first set of terms. Here's the second set. What do they both share in common? They both have sine. So we take a sine out. We're left with 2 cosine of x plus root 3 equals 0. Okay, so kind of like before, we took a greatest common factor of sine out. So we have sine of x equals 0. We have 2 cosine of x plus root 3 equals 0. The first one's already solved, so let's solve the second one. To get cosine of x by itself, we're going to subtract root 3. And we're going to divide by 2. Okay, so now they're both solved for either sine or cosine. We're looking for the radians. So where is the y value is going to be 0? All right, they're at 3 places, at 0, pi, and 2 pi. And then where is the cosine, the x term, going to be negative root 3 over 2? That is also going to be at 2 places. That's going to be at 5 pi over 6 and at 7 pi over 6. Okay, and there's your equations. Okay, next we look at the sum and difference identities. Okay, so again, make sure you have your formula sheet out for all these identities and all these unit circles questions that you have. All right, so for the first one, we have sine of 5 pi over 12. So you want to use the sum and difference identities for these. So to do 5 pi over 12, we're going to use, or I'm going to use, 3 pi over 12 plus 2 pi over 12. Okay, when we get these, you'll have pi over 4 plus pi over 6. Okay, so that's what we're going to use in our formula. So now if we do the sine and then x plus y formula for sum and difference, it'll look like this. It'll be sine of pi over 4, okay, times the cosine of pi over 6 plus the cosine of pi over 4, and then the sine of pi over 6. Okay, so now we go up to our unit circle and check out what these values are going to be. For sine of pi over 4, you're going to get root 2 over 2. For the cosine of pi over 6, root 3 over 2. For the cosine of pi over 4, root 2 over 2 again. And for the sine of pi over 6, 1/2. Okay, now we can combine or just multiply the values together. Root 2 times root 3 is root 6. 2 times 2 is 4, plus root 2 times 1 is going to be root 2, and 2 times 2 is again going to be 4. Now they have two fractions with a common denominator of 4. We can add them together. So we have root 6 plus root 2 over 4. Okay, on the test, please make sure you show your work just like I have. This is what I would expect you guys to be able to do, all right, for the test tomorrow. Number 12, okay, for cosine of negative pi over 12. So we can almost do basically what we just did. We're going to do 2 pi over 12 minus 3 pi over 12. And that will give us a negative 1 pi over 12. So we will have pi over 6 minus pi over 4. So now we go to the cosine sum and difference where it's going to be x minus y. So we have the formula would be cosine of pi over 6 times the cosine of pi over 4, right, plus the sine of pi over 6 times the sine of pi over 4. All right. Again, looking at the unit circle, if you don't remember what these values are, at cosine of pi over 6 is going to be root 3 over 2. Cosine of pi over 4 is going to be root 2 over 2. Plus, the sine of pi over 6 is going to be 1/2. And the sine of pi over 4 is going to be root 2 over 2. Again, we multiply the terms that we have, so we're going to get root 6 over 4 plus root 2 over 4. Combine the two fractions to get root 6 plus root 2 over 4. There is your answer. All right, I got one more to do for the sum and difference, and that is the tangent. So for tangent, I'm going to say let's do 8 pi over 12 plus 3 pi over 12. Okay. If we reduce 8 pi over 12 by, you can reduce it by 4, you're going to get 2 pi over 3 plus pi over 4. Okay. So if we use the tangent one, again, remember, when you do the tangent, instead of writing two separate identities as the formulas, we put them together because there's not really a lot of difference as far as the format, but there's the difference of the plus or minus. Since we are adding, we're going to use the top values, or the top mathematical sign. So on the top, we're going to get a plus. On the bottom, we're going to get a minus. So it looks like this. Tangent of 2 pi over 3 plus tangent of pi over 4 divided by 1 minus tangent pi 2, I'll get it, 2 pi over 3 times tangent of pi over 4. Okay, so now I got to figure out what these values are. So let's do that down here right below this question. So at 2 pi over 3, if we look at our unit circle, it's going to be root 3 over 2 divided by 1/2, negative 1/2. So we have to multiply by negative 2 over 1 to the top. Okay, all the stuff here on the bottom will cancel. The 2's will cancel and be left with negative root 3. All right. For pi over 4, we're going to get root 2 over 2 divided by root 2 over 2, which gives you 1. So we can now put these values into our equation. So tangent of 2 pi over 3 will be negative root 3 plus 1. And on the bottom, we're going to have 1 minus negative root 3 times 1. Okay, so that's what we're going to use going forward. So now I'm going to rewrite this just to make it cleaner as negative root 3 plus 1 on the top. On the bottom, I'm going to be doing 1 plus root 3 on the bottom. All right, the reason it's plus is because these two negatives here become positive, and then root 3 times 1 is just root 3. Okay, so this is a good spot we're at. Now, as mentioned before, we're not allowed to leave square roots on the bottom of your fractions. So we're going to multiply this to the top using the conjugate. We talked about the conjugate a number of times. The conjugate is the same terms at the bottom. That doesn't, there you go, there's a 3. It's multiplied to the top, and the difference is the sign between them. So we're going to change the sign. Okay. Now we distribute. Okay, negative root 3 times 1 is negative root 3. Negative root 3 times negative root 3 is positive 3. 1 times 1 is 1. And 1 times negative root 3 is negative root 3. All right, on the bottom, 1 times 1 is 1. 1 times negative root 3 is negative root 3. Root 3 times 1 is going to be positive root 3. And then root 3 times negative root 3 is negative 3. Okay, if we simplify this, on the top you're going to get 4 minus 2 root 3. On the bottom, like the conjugate was designed to do, these two terms will cancel themselves out. You'll be left with negative 2. Now from here, let's change the color just for a second. These three terms, if they are all the same, or sorry, not if they're all the same, if they can all be reduced by the same number, you must reduce them. Okay, if they can't all be reduced by the same number, then don't touch them. All right. So since they are all factors of 2, we can divide 4 by negative 2 and get negative 2. Negative 2 divided by negative 2 is positive 1. We don't need to write the 1, and then we have the square root of 3 left over. And there is your answer for the sum and difference of tangent. Okay. Next, we're doing the half angle formulas. Okay. So, for the half angle formulas, we're going to multiply this by negative 7 pi. Oh, let's make it bigger. There we go. We're going to take the value that we're given, negative 7 pi over 8. Okay. And we're going to multiply that by 2 to get negative 7 pi over 4. Now this one's a little bit tricky because negative 7 pi over 4 on the unit circle, if you go backwards around the unit circle and get to negative 7 pi over 4, this is the same thing as pi over 4. Okay, so we're not using negative 7 pi over 4 for this problem. We're going to use pi over 4. Okay, because again, on the unit circle, I'll draw it out here. To get negative 7 pi over 4, you had to go, let's change the color. You had to go backwards around the unit circle to here. This is negative 7 pi over 4. But we're not, we want to have something that's on the unit circle. So this is coterminal. If we went the opposite way and we went up, this would be positive pi over 4. Same thing as there. Okay. So we're using positive pi over 4 to figure out what our value is going to be. Okay, so if we put this into the half angle formulas, which is at the bottom right hand corner of your formula sheet, okay, we have let's go back to blue. We have 1 minus cosine of pi over 4 divided by 2, the big square root, and a plus or minus in front of it. Okay. If we look at the cosine of pi over 4 on our unit circle, you're going to get 1 minus root 2 over 2, divided by 2, the big square root, and a plus or minus in front of it. Now on the top of our fraction, we have 1 minus root 2 over 2. We're going to combine those using a common denominator. It will look like this. 2 minus root 2 over 2, and then divided by 2, the big square root, and a plus or minus in front of it. Now we have a complex fraction. This 2 is really just 2 over 1, so we're going to multiply by its reciprocal to the top of our fraction. All this stuff will cancel out. On the top, 2 minus root 2 times 1 would be just 2 minus root 2. And on the bottom, 2 times 2 is 4. Now, we want to square root the top and the bottom. The top really doesn't get square rooted because there's nothing to square root, but the bottom can be because the square root of 4 is just 2. So we would have 2 minus root 2 with a square root over it, and then divided by 2. Now, for the plus or minus, okay, we wanted this value here at negative 7 pi over 4. That was our original piece. Well, half of that, if you look at your angles, positive 7 pi over 4 would be 315. Okay, so if we took our calculators and took 315 and divided it by 2, we would get 157.5. So that would be on your unit circle here. This would be negative 157.5. Okay. All right, and now what I have to look at is the sine value at that spot. At this spot, what is the sine value? What are the y values of the unit circle on that spot? And they are negative because they are below the x-axis. So we're going to put a minus sign in front of our answer. And there we go. We're done. Okay. Number 15. So again, we're going to take our 11 pi over 12 and multiply it by 2 to get 11 pi over 6. So now we're going to take our half angle formula for cosine, which is 1 plus cosine of 11 pi over 6 divided by 2 with a big square root and a plus or minus in front of it. All right, so now we do the cosine 11 pi over 6. So the x value of 11 pi over 6 is 1 plus root 3 over 2 divided by 2, the big square root and a plus or minus. Again, like the question before, we want to combine the two fractions on top of 1 plus root 3 over 2 to get us 2 plus root 3 over 2, all of it being divided by the 2, the square root and plus or minus. Again, like the question before, we're going to multiply by our 2 on the bottom, which is 2 over 1, so we're going to take its reciprocal and multiply it to the top. This cancels out the whole bottom part. We get 2 plus root 3 over 4, with a big square root in front of it, and a plus or minus. Again, we are square rooting both the top and the bottom of our fraction. On the top, you're not going to square root anything. You're just going to show that you're going to keep square rooting it. But on the bottom, the square root of 4 is 2. Now, just like before, for the last question, we had to find out where 11 pi over 6 is on our unit circle. So 11 pi over 6 on our unit circle is right here. Okay, that's 11 pi over 6, which is 330 degrees. If we divide that by 2, because we're doing half of that angle for 11 pi over 12, it's 165. 165 is going to be over here. So this is 330. Half of that is 165. So what is the cosine values over here in this quadrant? In that quadrant, the cosine values are all negative. So our answer is going to have a negative sign in front of it. All right, one last question, and then we're done with the review, which is the tangent. So for tangent, for half angle, we have 7 pi over 12. So we're going to take 7 pi over 12. We're going to multiply it by 2. We're going to get 7 pi over 6. right, so our formula, we have 1 minus cosine of 7 pi over 6 divided by 1 plus cosine of 7 pi over 6. The big square root of the plus or minus. So we were looking at the cosine of 7 pi over 6. 7 pi over 6 is going to be negative root 3 over 2. So we're going to have 1 minus negative root 3 over 2 on the top, and 1 plus negative root 3 over 2 on the bottom. Again, big square root, plus or minus. Sorry about the messiness of the square root. All right, just like before, but now we have to do it on the top and the bottom of our fractions. We have to combine our numbers. So common denominator is going to be 2. So we're going to have 2 plus root 3 over 2 on the top. It's going to be plus because the two negatives make a positive. On the bottom, you're going to have 2 minus root 3 over 2. All of this under a big square root with a plus or minus in front of it. All right, now with our complex fraction, we're going to multiply by its reciprocal. So all this stuff will cancel, and the 2's will cancel. And we will be left with 2 plus root 3 on the top, 2 minus root 3 on the bottom, the big square root and a plus or minus. Now, like the previous tangent problem we had where we had to do the conjugate, we have to do that here too. So we can't have square roots on the bottom of our fractions, so we're going to multiply by the conjugate, which is 2 and root 3, with a different sign between them than the one we had originally. So it was a minus, now it's a plus. Again, this has nothing to do with the top of our fraction being 2 plus root 3. It's that the conjugate is what it is. So we multiply this out using distributive property. I'm going to go across here. 2 times 2 is 4. 2 times root 3 is 2 root 3. Root 3 times 2 is 2 root 3 again. And root 3 times root 3 is 3. On the bottom, 2 times 2 is 4. 2 times root 3 is positive 2 root 3. Negative root 3 times 2 is negative 2 root 3. And negative root 3 times positive root 3 is negative 3. Okay, if we combine the terms, we're going to have 7 on the top plus 4 root 3. On the bottom, these two terms, like they're supposed to, will cancel out because of the conjugate, and then 4 minus 3 is going to be 1, with a big square root and a plus or minus. The square root of 1 will just go away, so we have 7 plus 4 root 3 with a big square root on top of that. We don't need the 1 on the bottom because the square root of 1 is 1. Now what we have to do is figure out the value here. So if we look at our unit circle, we're looking at 7 pi over 6. 7 pi over 6 is going to be right here at 210 degrees. I use the degrees because they're easier to calculate than doing the pi's divided by 2. So we're looking for 105. So 105 is going to be here. So we want to know what is the tangent in this quadrant. And the tangent of this quadrant is 1 is positive, 1 is negative, so it is going to be a negative value. And that is the end of the review. Now the good news is if you've stuck around for the end of this video, the test is actually pretty short. There is one tangent question, and you can use either sum and difference or half angle. Either one, your pick. It doesn't make a difference to me. All right, so good luck on the test tomorrow. Please make sure you do the test, and we'll talk to you soon.